Well, hi everyone. As you know, we have talked about triangle congruency in Chapter 4. Before we start with Section 4.6, I wanted to point out to you a few additional theorems that are not in your textbook that we will be utilizing. The first one is Theorem 4-2-6, and it states that every angle has exactly one bisector. So what we can do with that, especially in this chapter, is if I wanted to create two triangles for some reason, and this isn't for a particular problem, this is just in general. If I wanted to bisect this angle, the reason I could do it is that every angle has exactly one bisector. So I could say construct AD bisecting angle BAC. And the justification that I would give in a proof is that every angle has exactly one bisector. Another theorem that's not in your book that is very useful, that is in many other geometry books, is that every segment has exactly one midpoint. So again, to add these auxiliary lines, this is another reason or method in which I can use to draw an auxiliary line in my diagram. So let's say, for example, I have this diagram. I could construct point M as the midpoint of line segment AB. And the reason, again, that I would give in a proof is that every segment has exactly one midpoint. Now that I have this point, I can connect the two, construct line segment XM by the line postulate, because between any 2 points is exactly one line. So those are ways in which you are going to utilize the concept of adding auxiliary lines in some of your proofs if you find that it's necessary. So I wanted to make sure that you had that knowledge as we move forward. So moving on to Section 4.6. In terms of the assignments that you're going to be doing, is we're going to be covering pages 16 through 20 in the packet. And you'll notice that in page 18 is a duplicate, so you don't have to do that one twice. So the whole focus of Section 4.6 is this one phrase that's is abbreviated to CPCTC, and it stands for corresponding parts of congruent triangles are congruent. Now, remember that we've just spent some time there's 5 different ways to prove triangles congruent: SSS, SAS, ASA, AAS, and HL. Now, once we've proven that triangles are congruent, then all of the other corresponding parts, the angles and sides, are congruent as well. So, as we move forward, and I'm going to do some practice problems with you out of the assignments so that you can see them, is that we will be proving triangles congruent, and then from there we can say that the corresponding parts are congruent, and then from there we can even say more. So for example, if I was able to prove that alternate interior angles were congruent, then I could prove that lines were parallel. If I could prove that I have right angles, then I could prove that I have perpendicular lines. Or I could prove that I have an angle bisector, or I could prove that I have a midpoint. So once I've proven that the two triangles are congruent and proven that their parts are congruent, I might be able to prove additional things. So let's take a look at one general proof, and it's this one right here. Given that the segments are equal and one pair of angle measurements are equal, we want to prove that angle A is congruent to angle D. So you notice here that I have overlapping triangles, and that's something that you're going to have to get used to. It's a little visually challenging. And I marked up my diagram. So here I have AB and DC are equal to one another, and then these angles measures are equal to one another as well. So the first thing that I'm going to do is I'm going to copy down my given information. and because the lengths are equal and the measures of the angles are equal, then they are congruent to one another by definition of congruency. So what I'm looking at here is I'm looking at these two overlapping triangle ABC and triangle DCB. If I can prove that those two triangles are congruent, then I can prove that these two angles, their corresponding angles, are congruent. So moving forward, again, I've already proven that one pair of sides are congruent, one pair of angles are congruent, and if you notice, BC is congruent to BC by reflexive property of congruence. And we then can state that the two triangles are congruent by SAS, and therefore the angles are congruent by CPCTC. Corresponding parts of congruent triangles are congruent. So everybody make sure that you have this completed proof. Next, what we're going to do is I'm going to just walk you through a couple of the proofs that you are assigned. So what I would like you to do is maybe try this first problem, this first proof, and once you're done, come back on and check your answer. Now, in some cases, there's more than one way to do the proof, so if you feel very confident that you did the proof correct, you could email me and ask me a question, or you can just wait till class. So here we have a bunch of given information, and we're trying to prove that PX, line segment PX is congruent to line segment PY. You'll notice that I added angle numbers in here to help me make this proof a little bit easier. So here I have the given information. Now you notice that I only wrote down the one major piece that I have an angle bisector. And the reason why I did that is because I followed it up by saying angles 1 and 2 are congruent to one another by definition of angle bisector. Next, I introduce the other piece of given information. And what does perpendicular give me? Perpendicular gives me right angles. So I know angles 3 and 4 are right angles by definition of perpendicular lines. And if they're both right angles, then we know that they're congruent to one another. All right angles are congruent. Right angle congruence theorem. And so as I mark up the diagram, I know angles 1 and 2 are congruent. I know angles 3 and 4 are congruent. And the other piece of information that I know, I should probably put double hash marks on this one to show that that's two separate pairs. I have line segment BP is congruent to BP by reflexive property of congruence. And then that gives me enough to say that the two triangles are congruent by AAS. Make sure when you state the triangle congruency that you're matching up the vertices. If not, it would be incorrect and you would be marked down. So now that I know that the two triangles are congruent, then I can say that the parts are congruent by CPCTC. So check yours out. Put the video on pause and try problem number 4 now. We're going to go over that one. So the deal with problem number 4 is that there's a whole bunch of triangles here, and there's more than one way to do this proof. I'm going to tell you right now. I did it one way, but you may be doing it another way, and it's still valid using a couple of transitive property steps. So I wrote down all of the given information. Again, in this particular case, it might be that depending upon the strategy that you used, you did not use all of the given information. So here, I wrote down the given information. I noticed that in this diagram, I have angles 1 and 2 are congruent by vertical angles theorem. And now this is where my strategy might differ from your strategy. The given information says that angles M and N are congruent. Therefore, that makes these lines parallel by AIP. And if these two lines are parallel by AIP, then guess what? These two angles, angles K and T, are congruent by PAI. We already have given that this segment is congruent to this segment. So lo and behold, this triangle here is congruent to this triangle here by ASA. And again, once we know that the two triangles are congruent, then I can say that their corresponding parts are congruent here by CP/CTC. Okay, so one more proof is going to do it today. You're going to have to do the rest on your own. Let's go now to the worksheet that starts off with 4.6 triangle proofs. And I just want to walk through problem number 2. So put this on pause, see if you can do problem number 2 yourself. When you're finished, come back and check your answers with me. And again, there may be more than one way to solve this proof. Trying to look for a clean piece of paper that I can use. Okay, so the given information in this proof, and I marked it off on my diagram. I have that LF and KF are congruent, LA and AK are congruent. Now again, there's a whole bunch of different triangles here. What I'm going to do is I'm going to first focus on these two triangles here, this triangle here and triangle FKA. And I'm going to see if I can prove that those two triangles are congruent. You'll notice that I have the two sides congruent, and then by reflexive property I can say that FA is congruent to FA. Therefore the two big triangles are congruent by SSS. Now this is where you and I might differ in our approach. What I'm going to do is I am going to focus on these two triangles here, this triangle here and this triangle here. If the two triangles are congruent, then angles 1 and 2 are congruent by CP/CTC. Then I'm going to say that FJ is congruent to FJ by reflexive. And so then that makes these two triangles here congruent by SAS. And once I know these two triangles are congruent, then I can say that LJ and KJ are congruent by CP/CTC. So here's my proof. Now somebody else might have said, hey Manoogian, what I did after I proved the two big triangles congruent, I proved these two small triangles down here congruent. I said that these two angles were congruent by CP/CTC, and this was reflexive, and therefore the two triangles congruent by SAS using these two triangles. That's perfectly fine. So again, I hope you have some fun with the proofs. That's the focus of the asynchronous assignment, and hopefully you'll be well prepared for the test on Friday. See you later.